Yes, sir.
So in our today's class, we are going to see the next concept. So I think yesterday we solved some numericals also related to the previous concepts and all. Law of conservation of energy, that conservation of momentum, etc. In today's class, we are going to see the next interesting thing. That is what we are going to make laws of simple pendulum also in our today's class. So in that, before going to start that, we are going to make a certain kind of motions. So that is what the first kind of motion which we are going to study is periodic motion. Okay, so please keep heading periodic motion. Many types of motion is there, but what is necessary for you now for understanding the uh, laws of motion, that is what we are studying now. So periodic motion. So what do you mean by periodic motion, and where we can notice in our daily life? If we observe any kind of motion, you remember, which repeats itself after equal interval of time is known as periodic motion. Means same action is continuously repeating with the equal interval of time. So that is the motion we used to call it as what? Everybody? All of you? Periodic motion. Okay. So if you take, for example, revolution of the earth, after how many days again it will start from the basic? Suppose if I consider the sun, so around the sun, earth is keep on revolving. After how many years it will be again starting? Suppose this is the initial position, January 1st. So January 1st, again next January 1st, again it will come to the same point. Am I right or wrong, everybody?
365 days.
Yes. So within 365 days, it will take one rotation. Like it will take 1 year to make one complete rotation. Am I right or wrong, guys? Please respond. And that rotation will never stop. 2023, 2024, 2025, like every time the same motion is repeating after every equal interval of time. So that is what we used to call as periodic motion. All of you remember? A motion which repeats itself after equal interval of time is known as periodic motion. So, if you take for example, how many of you are having a wall clock with pendulum wall clock? You might be remember ting 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 ting, like that it is. We keep on making sound. I remember everybody. So there is a bob, pendulum bob, which will be keep on oscillating towards to the left and towards to the right. It is making tick, 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 continuously same motion. It will be repeated. Am I right, everyone? You might be notice it. Wall clocks, clocks theriyada. All of you. Please respond. Clock, you don't know. Wall clock, periodic clocks. Yes, please. So that is also we can say periodic motion. Means the pendulum of a wall clock is continuously motion. Church and all, you can notice it. A big wall clock will be there. Yes, Clark? Please respond, guys. Temples also we can notice it. Pendulum clock. You have seen or not? At least that you tell me.
Yes, sir.
Yeah. So pendulum clocks, many of you have seen. So what will happen? That oscillation, that continuously it will be the bob of this pendulum clock keep on making this side, left side, right side, left side, right side, left side, right side, left side, right side. It will be keep on making. Am I right or wrong, guys? Everybody? Yes or no?
Yes, sir.
So that is also we can say periodic motion, because after every interval of time, after the same interval of time, it will be keep on repeating itself. Nobody is making to push. It will be keep on repeating itself by its own. So that is why it is called as, we can say, periodic motion. So I hope everybody understand what is periodic motion. Yes, please. Write it. A motion which repeats itself, a motion. So why you are teaching this, sir? You will understand it. Repeats itself after equal interval of time. After equal interval of time is known as what? Periodic motion. So what is the examples you can take? The pendulum of a wall clock, or you can take earth revolving around the sun is an example of what? Everybody. Is an example of respond periodic. Okay, or else swing. Yes, very good. So for example, if you take any kind of a spring, and if you have been attached to mass, of course, there is no air friction or something. And if you press it and if you release it, it will be keep on oscillating. Am I right or wrong, guys? Going up and coming down, going up and coming down, going up and coming down. Of course, it will come to rest because of air friction. I'm not saying about air friction. Generally, the spring, the suspended, the oscillations of a mass suspended from a spring. If you suspend the mass for a spring, the oscillation of the spring is also example of what? Everybody. Periodic motion. Clear, everyone? So that is what do you mean by periodic motion? Next, oscillatory motion. Oscillatory motion. What do you mean by oscillatory motion? Anybody? Oscillatory motion, if oscillations are very faster, we can say that is only called as, we all can call it. If a more number of oscillations it is making, then we used to call it as the same oscillatory motion, we used to call it as what? Everybody. Yes, please. Vibratory motion. Okay. So what do you mean by this one? Remember, it is a periodic motion in which body moves to and fro motion repeatedly from its mean position. Yesterday, when we are studying about the pendulum, law of conservation of energy, so the midpoint is called something. I taught you. What is the position, anybody? The midpoint is called as mean position, and it will keep on oscillating. It will take to this side, it maybe comes to here, and again this side also it maybe comes to here. So that is what these positions are called something. Anybody can tell these two positions are called as? Yes,
extreme position.
Extreme position. So from the mean position, if any body is making to and fro means coming forward and going backward, coming forward and going backward, coming forward and going backward, oscillating like this. So that is what we used to call as oscillatory motion. If this number of oscillations are many, then very fast for a less number of time, like which is for a less period, more number of oscillations, then that oscillatory motion only we used to call as what? Everybody? We used to call as, please respond. Vibratory motion. That is what you have to remember. Is it okay, guys? Everybody? Understand? Please respond. That is what. So please write it.
Sir.
It is a periodic motion in which it is a periodic motion in which the body moves to and fro motion. To and fro. What do you mean by to and fro? Going forward and coming forward, backward. To and fro repeatedly. About its what point? About its what point? Repeatedly about its what point, guys? About its mean position. Okay. So that is what we used to call as oscillatory motion. So what is the example? In lower classes, you might be getting some other example also. U-shape one thing will be handled. What is that called as? Anybody? If you hit it with a rubber hammer, it will be keep on oscillating to and fro motion. Sound chapter, you will be study that. Anybody name it?
Tom.
Yes. Tuning fork. Okay, ma? Vibrations of tuning fork. Okay, is called as oscillatory motion. I hope everybody understand. All of you. Tuning fork spelling Tuning and fork F-O-R-K-4. Anyone having any doubt, you can ask me. All of you understand, Amma? Please respond.
So periodic motion is similar to oscillatory motion.
Yes. Okay.
Yes, sir.
Yeah, but every periodic motion is not a oscillatory motion. If it is a oscillatory motion, means it has to make to and fro motion. Do you understand, Mari?
Yes, sir.
That is what. That is why every oscillatory motion is a periodic motion, but every periodic motion is not a oscillatory motion. Clear?
Yes, sir.
Understand, everybody?
Yes, sir.
All of you, that is what. Next, Simple harmonic motion, SHM, very, very important one. SHM, simple harmonic motion, most important type of motion. 11th, 12th, everywhere it will be. SHM, simple harmonic motion. So what do you mean by simple harmonic motion means? So for that, let us take one pendulum. So we all knows that pendulum, one end is attached. Even yesterday I have taught you. One end is attached to the rigid surface. So that is what is the point we is to call. What is the point we is to call? Everybody. We is to call as pivot point. What is the point we is to call? Pivot point. And there is a length string. The string having a length of L. What is the length of the string, everybody? String L. And there is a bob attached at the free end. A bob attached at the free end. Now, what is this position called as? Anybody can tell? Mean position. What is to call? Everybody? Mean position. Now, from mean position, if I take it into the A point and if I release it, so here, if you notice it here, the displacement, what is the displacement? If the mean position, if I leave it, what is the displacement? No displacement body shown. So what is the displacement? X means what? X means what, guys? Displacement only. Do you understanding, all of you? So X means displacement. So displacement is equals to what? At the mean position, displacement is equals to what? It went to final. Initial point and final point is same. Am I right or wrong? So that displacement is equals to how much? 0. Clear? Now, if it has been taken to the A point, so I am considering displacement is a what? Like a forward direction. So what is that? Positive or negative? Forward direction, positive. If I'm, that is what fro, to and fro motion. So to and fro motion. So I am taking this side, it is going, so positive, and back side it is going. I am taking as a what? Everybody. It is taking as what?
Negative.
Respond. Negative. So whatever the direction you can take, either, for example, I'll take Mr. Mari to take this bob into A point and leave it. Or Mr. Lingesh to take the point into C point and leave it. Wherever I will leave it, it will finally will come to the which point? Anybody can tell me? Finally, it will come to the which point? Mean position. Am I right or wrong? Please respond. All of you. Yes?
Yes, sir.
So,
Yes, sir.
the restoring force acting on a body from its mean position is directly proportional to the displacement from the mean position. So that is what is only called as simple harmonic motion. Means the restoring, all of you remember, the restoring force. For example, I will ask Mr. Mari to take, and he has been taken to from this much height. Now you tell me the force exerting to come into mean position is more or less? More or less. Anybody? This is the height here, H, and this is the height here, H. So height increases. So energy force also increases or decreases? Anybody?
Jesus.
Yes, increases. We all studied or not? Shivani, understand? Agalya? Yes or no?
Yes, sir.
So if the bob is going more away from the mean position, then the restoring force means the force creating in the bob is also more. Am I right or wrong? So it is directly proportional or inversely proportional? Everybody. Directly proportional to each other. If I take this bob to this much height, then more force will exert or less force will exert? Anybody?
More force.
More force. Do you understanding, everyone? All of you?
Yes,
Mean position, initial point and final point is same. Initially bob is here and finally also here. So that what is the displacement? Anybody? Initial and final point is same. So the displacement is what? 0. Am I right or wrong, guys?
Yes, sir.
Yes. Now, if I take this bob to this position, now you tell me, here it will, the restoring force, the force will be greater or lesser? Anybody?
So, what is memory restoring force, sir?
Means trying to bring it back to the same point. Try to bring it back to the mean position. That is what restoring force we can say.
Yes,
Okay.
sir.
Yeah. Now you tell me at this point, it will like the string is having more force or less force to coming back. Anybody? Yes, please. It is going more above from the ground so that the force created, the energy. What is that energy? More above from the ground. Which energy it is? Everybody. Elevation going above from the ground. What energy will create? The
The
work done by
potential
a body
energy,
which is
sir.
equals to what? Yes.
Potential energy.
The work done by a body which is equals to potential energy. Am I right or wrong?
Yes, sir.
That is what it is I'm saying. So, if always remember the restoring force, the force which is trying to come to its same point, initial point, is directly proportional to the displacement from the mean position. So, how much body has been displaced from the mean position will decides the force which is trying to come back to its mean position. So that is only called as simple harmonic motion. So simple harmonic motion means, okay, so please all of you write it. It is an oscillatory motion. It is an oscillatory motion. Simple harmonic motion is a what motion? Everybody? It is an oscillatory motion. Write it. Oscillatory motion in which, Gokul Purima, in which the restoring force. What do you mean by restoring? The force which is trying to come back to its same position, mean position. Understand, Shivani? Agalya? Restoring force acting on a body, is directly proportional to its displacement. Displacement from the mean position. Do you understanding, everybody? Lingesh, Kavya, Alfin, are you writing the notes? Hasinis also, both Hasinis. I want to know. Everybody clear?
Sir,
Yes.
we can say this as an example of both oscillatory motion and
Oscillatory.
periodic
Yes,
motion.
yes, we can say that. Clear? Understand,
Sir,
Mari?
as a periodic motion, what type of function it is, sir?
What?
As a periodic motion,
Hmm.
what type of activity it's doing, sir?
Here.
Yes, sir, in the moving pendulum.
Moving pendulum, what activity is it is keep on moving to and from motion, coming forward and going back. And it will be always whatever the position. See, if I try to take to this point, now theta will increases or decreases. For example, I brought to here. The angle from the mean position, the angle will increases or decreases theta. Yes, please.
Increases.
Increases. So that it is going above from the ground, little bit more. So that the force which is trying to come back, more faster it will come to the main position. Do you understand? Like a swinging,
Yes.
guys. If suppose your sister is swinging, you can see that if you take it into the less distance, then she will jump also less distance. If you take it more back and if you release, then she will make more big oscillation. Am I right or wrong? All of you?
Yes, sir.
Yes, the same thing here. The restoring force, the force which is trying to come back to its mean position is increases, and it will be depending on it will be directly proportional to the displacement from the mean position. So if the bob is going more far away from the mean position, then the force created by it also more or less. Everybody, it will be creating more. That is what you have to remember. Is it okay, guys? All of you? Please
Yes, sir.
respond. That is what it is. So this is what three types of forces. One is periodic motion, another one is oscillatory motion, next one is simple harmonic motion, SHM. Now, always for everything I am saying, the pendulum is an example. So let us study what is this pendulum, and then we are going to see what is the loss of simple pendulum. Okay. So all of you observe, pendulum consists of a bob. This is only again I'm going. Pendulum consists of a bob suspended by a string. Understanding? String whose length is what? L. Understanding, all of you? L, and a rigid support which is attached to the wall. One end is attached to the wall. That is a point which is called as what point? Everybody? All of you respond. That is point we used to called as rigid pivot point. So this is only we used to called as simple pendulum. So simple pendulum means rigid support, string, and as well as bob. So these are the three things. And this string is, remember, this string is actually inextensible string. What do you mean by inextensible string? Anybody can tell? Inextensible string. I want to know how many of you know the meaning. Girls?
It doesn't have any elasticity, sir.
Yes, zero elasticity. If I take a perfect length, that same length it will be. Understanding, all of you? Sangamitrai, inelasticible means in the sense of, inextensible means no further elastic in nature. So always the length of the spring remains constant. Understanding, girls? Everybody, boys? So that is what is called as simple pendulum. Now, when the bob is pulled to a one side and released, then what it will do, guys? Now, for example, I have taken to this position and I release that bob. So then you notice something. The bob will start doing something. To and fro motion. Am I right or wrong? It will go to again C point and it will come to the B point and again come to the A point. Again go to the B point, again go to the C point, again come to the B point, again go to the A point. Am I right, guys? Please respond, everybody. Yes or no? If there is no air friction, continuously it will be in the same path. Am I right or wrong, guys? It will go to C to A to C and again C to A. It will be continuous motion. Am I right? Please respond. To and fro motion. So that is only means when the bob is pulled to anyone, either this side or this side, it will be continuously making to and fro. To and fro only we used to call something. What is that called as? Everybody. To and fro is called as what? All of you.
Oscillatory.
Oscillating. Understanding? So, now if you notice it here, from the mean position, observe very carefully. So, pivot point is there. All of you observe, this is the bob. And this is the point, I will take it as a pivot point. What point I will take, everyone? Pivot point. So for making oscillating, I am taking into particular angle and I am taking into this position and then I am releasing. Am I right or wrong, guys? Everybody, will you all agree with me? Please respond. Everyone? Yes?
Yes.
Yeah.
Yes,
By
sir.
the time, you can notice it from the mean position to the extreme position, there is an angle between that. Do you all understanding? So this is only called as it is displacing, showing the displacement with the angle. So this is the displacement we used to called as angular displacement. Mr. Sanjay might be have idea about it because he studied in Akash classes. Angular displacement. Do you understand it? It is displacing. See, if a body displaces in a straight line, what is the theta? Theta is equals to 0. Am I right, everybody? So we can say no theta is existed. But here it is displacing with a certain angle from the mean position. Am I right or wrong? Everybody? Yes? So that is why this displacement is called as not normal displacement. This is called as what, everybody? All of you. Angular displacement. What is to say? Angular displacement. Okay? So write it. Write it. Angular displacement. Angle which the bob makes with the angle which the bob makes with the vertical is called angular displacement. Angular displacement. What is the symbol of angular displacement, everybody?
Theta.
Theta. Okay. If A is the mean position, A is called as what? Anybody can tell me? A is the mean position. Okay. Then OA is called as what? OA is called as vertical line. Clear, everybody? OA is called as vertical line and theta is called as what? Anybody? AD. AD means what? Angular Angular
Displacement.
displacement. OA is called as, what is that OA called as? Vertical line. Vertical line, and theta is called as angular displacement. That is what you should learn it. So simple pendulum means a bob
Then
with
can we say BA and CB shows angular displacement?
which one, Mare? Yeah, you want, you can show us that. B, this is a A I am taking, then this point, if we consider as a B point, then we can say angular displacement is this, like a triangle it will form. So OB is the angular displacement. Angular displacement is theta. This is what, how much it is moving. That is only theta. Okay, Mari?
Sir.
Yeah.
Sir,
Now, yeah.
can we take totally like ABC?
Yeah, you want, you can take it. Angular displacement means nothing. From the mean position, how much angle it is moving. That is the theta is called as angular displacement. Understand, Laksha? Nothing is there big thing in that understanding. The theta, how much it is going above from the mean position with what angle. See, if I'm having a pendulum, I can take to this angle, or I can take to this angle, or I can take to this angle for releasing. Am I right or wrong? Everybody clear? So if it is making here, this is the angular displacement. If I take to this much, this is the angular displacement. If I take this much, this is the angular displacement. Are you clear? Understand, guys? Girls? Okay, Shivani?
Yes, sir.
Yeah.
Yes,
So that is
sir.
what you should remember. Okay. So now what will happen if I make this angular displacement? It will be keep on oscillating. Am I right or wrong? All of you? So it will go to the, if I take to the A point and if I release it, it will go to the B point. From B point to again, it will go to the C point. And again from C point, it will come back from to B point. And again B to A, it will go. So that imagine there is no air friction. Then it will be continuously making something. That is what we is to called as. What is to call? Anybody? What is to say? Oscillation. What is to call, everyone? Please respond. Oscillation. Okay. So now,
Oscillation.
what do you mean by oscillation? Let us understand it. So for example, if I take a pendulum, all of you remember, this is a rigid surface, pivot point. So mean position is A. What I will take, sorry, B, let me take A point. Mean position is A. I have taken and I have made angular displacement is theta. How much angular displacement? Everybody? Theta. And I went to the B point. Now I released. So body is starting from which point, guys? A point or B point? Body is starting from which point? B point. So it will go to B to A, and the same this side it will come to the C point. Okay, everybody? And again it will go from C to A, and again it will come to the B point. So it is started from B and it will come back to the B. Then we can say it is completed how many oscillation? Anybody can tell? How many oscillations?
One oscillation.
One oscillation. Understanding? One to motion and one fro motion. Completely is called as one oscillation. One complete to and fro motion is called as one oscillation. All of you should remember that. Is it okay, guys? All of you? Yes?
Yes, sir.
All of, please respond. Any doubt you can ask me. Agalya, understand Agalya? Mari, Lingesh?
Yes, sir.
Yes.
No, sir.
Next. Now, for example, I am having a one simple pendulum, small, and I have taken to maximum. You can see that. The maximum displacement of the bob. For example, this is the what position we can call? Mean position. Am I right or wrong? Everybody respond. Mean position. Now I ask Mr. Lingesh to take the bob to this much height. So now I ask Mr. Kishore to take this much height. Now he has been taken. Now tell me, let me take this is H1 and this is H2. So whose height is maximum? H1 is maximum, H2 is maximum. I take some other pendulum. I asked Mr. Nivedan to take another pendulum. He took little bit longer and he has been taken to some other thing. So very, very long height from the mean position. So that this is H3. Now tell me, who is having greater height? H1, H2 or H3?
H3.
H3. So the maximum displacement, who is traveling maximum displacement from the mean position? H1 or H2 or H3? Maximum displacement. Anybody?
H3.
H3. So everywhere it is traveling some displacement from the mean position. That is only called as amplitude. What is to call, everybody? Who is to called as what? Please respond.
Amplitude.
Amplitude. So write it. It is the maximum displacement. Amplitude means it is the maximum displacement. It is the maximum displacement of the bob from its what position, guys? Always you should take from its what position?
Mean position.
Yeah, from its mean position. Nivedan, understandara? Lingesh? Yes? What do you mean by one oscillation? Anybody can tell me? Oscillation means
Sir,
what?
1 to 1.
Yes.
1 to 1 promotion.
Yes. From one extreme position to the other and back to the starting position. Going from one extreme position and it will go to the another extreme position and it must come back to the what? Same starting point. Clear? Going to the another extreme point and coming back to the same starting point. Then we can take it as a what? How many oscillations? Everybody?
1 oscillation.
One oscillation. Understanding? One extreme position to the other and back to the starting position is called as how many oscillations? Girls? See, for example, Bob is starting from A. It will go to the what? Another extreme position. What is another extreme position? Everybody? C. And again it will come back to the A. Then we can consider as how many oscillations? Everybody? It is completed. Respond. One oscillation. Okay. Starting from one extreme point and going to the another extreme point. And come back to the same position. Same initial position. Then we can say it is make one oscillation. Understanding, girls? Shivani, Alfin, Abhirami, any doubt you can ask me. Hasinis, both Hasinis. Understood, Amma? Everybody? Clear?
Yes, sir.
Now, going from one extreme point to another extreme and coming back to the same point, we used to call it as what, everybody? Oscillation. One oscillation. So, the time taken for completing one oscillation is only called as period, or we can say time period. Period, or simply we can say what? Time period. So, time period means what, everybody? Time period means what? Time taken by the pendulum to complete how many oscillations? Fastly.
One
oscillation.
One
oscillation.
oscillation. Time taken, time taken by the pendulum to complete how many oscillations? Fastly. To complete one oscillation. Okay. So is only called as time period. So what is the time period? Capital T. Okay. Next. For example, in 1 minute, in 1 second, how many seconds? In 1 second, okay, it made, for example, 10 oscillations. How many oscillations? Example, I'm saying 10 oscillations. Then, what is the time period? Anybody can tell? It is making
1 second.
Yeah, 1
1
second.
second.
Ayyo, 1 second, 10 oscillations, girl. So 10 oscillations is equals to 1 second. Then what do you mean by time period? 10 oscillations or 1 oscillation? Anybody? 10 oscillations or 1 oscillation? Time taken for how many oscillations? 1 oscillation. So that time for 1 oscillation is equals to 1 by 10 seconds. Am I right or wrong? Everybody? Yes, please.
Yes,
Very
sir.
good. Yeah. So that is what. So this is the time for 10 oscillations. 10 oscillations, 1 second. Then 1 oscillation is equals to what? Everybody. 1 oscillation is equals to 1 by 10 seconds. Okay, guys. Abhirami, what is this? For example, you are making 10 oscillations for 10 seconds. Then can tell me what is the time taken for 1 oscillation? Anybody? Time taken for 1 oscillation. Please respond.
1 second.
1 second.
Okay.
Same way now, instead of 10 oscillations per 10 seconds, not 10 oscillations per 1 second it is making. So what is the time taken for 1 oscillation? Anybody? Time taken for 1 oscillation.
So 0.1.
1 by 10 seconds means 0.1 second. Am I right or wrong? Will you all agree with me?
Sir.
Yes, Abhirami, understood?
Yes, sir.
Yeah. So that is only. So if you take the time taken for one oscillation, what is to call, guys? Time taken for one oscillation. What is to call? Time taken for one oscillation. We is to call something. Everybody. It is called as time period. Time period. Okay. Now there is another one which we is to call frequency. Note it. If you note this only, we can study laws of simple pendulum. That is why. Frequency will represent with a small f. Frequency means, write it. It is the number of oscillations. Sangamitra, are you writing? Take the notes properly. Number of oscillations made by the pendulum. Made by the pendulum, because we are studying about the pendulum or oscillating body, any body in 1 second. So means number of oscillations per 1 second is called as what? Everybody. Number of oscillations per 1 second is called as what? Everybody. Frequency. Okay. So all of you remember, frequency is equals to 1 by time period. Always both are inversely proportional to each other. Or time period is equals to 1 by frequency. So whatever you want, you can write it. So frequency is equals to 1 by time period and time period is equals to 1 by frequency. So time taken to complete one single oscillation is called as time period. Means one going and coming back. If it is making 10 oscillations per 1 second, that is called as frequency. Is it okay, guys? All of you? Yes? So frequency means, simply if you want to say, frequency is the cycles, that is what? Oscillations per second. Oscillations per second. This oscillations per second, in the honor of scientist name called as Henry Hertz, we will write the unit of frequency is Hertz. Okay, all of you? Hertz is the unit of frequency. Please write it. What is the unit of frequency? Unit of frequency. Hertz. Hertz means what? What do you mean by Hertz?
Unit of frequency.
Yes, unit of frequency. HERTZ. Sorry, DZ illa TZ. Unit of frequency. What do you mean by Hertz? Anybody? Cycles per
Second.
Cycles per second. Cycles per second. Cycles means what? Bicycles are oscillations. Oscillations per second. That is only Hertz. Okay. So this is what it is. Meeting is going to end. Join back so that we will study laws of simple pendulum. Okay. So please make it. Laws of simple pendulum.